In this video, we're going to talk about the idea of sorting information. Now that we've got a lot of information loaded in, maybe into an array, we may want to do something with that information that requires us to sort it. So for example, if we have loaded in 208 names, and I got these from a random website name generator, 208 names here, it's hard to tell just by looking. For example, is the name Sasha on here? We'd have to look through every single name and find Sasha, and it's pretty easy to miss it even if it's on here. How about the name Mark? It's hard to just look at a huge list of names and find the name or know for sure that it's not on there. And 208 names isn't that big. Picture using Dominican with 4,000. Or picture a dictionary where if you're trying to find a word but they're in no order whatsoever, how hard it would be to find the definition for a word. So we do exactly what a dictionary does. We sort the words. Now if I ask you, is Sasha in here? It's really easy to find Sasha. And sure enough, she is. If I ask you, is Mark in here? Nope, no Mark. That's pretty easy. You find the word that would go before it, you find the word that would go after, and you know that there's no Mark in between. I could also ask you, is there a duplicate? Are there any names that are in here twice? And if I show you the random list of names, that is really hard to find. I'll maybe start with the first one, LaDonna, and try to quickly scan through to see if LaDonna is in there. And I don't see her, but I'm not super confident in that. What if I sort them? Well, if there are two identical names, they'd be right after one another. So all I have to do is look at the two names in combination, and I can pretty quickly spot some that are identical. Leticia, I see jumping out at me, or Janessa there. Leroy, I see, is duplicated. I can do this just by scanning through the list, because if the name is in there twice, it'll be in there one right after the other. So how do we go about sorting a list of something? Well, we're going to use one of the most simple sorting techniques called bubble sort. I'm going to demonstrate this using just some rectangles. We're going to try to have the rectangles go smallest to largest, left to right across the screen. And the way bubble sort works is it's going to take a pair. So we'll just look at the first two, and we'll say, are these in the right order? We want smallest to largest, so they're not. We need to flip them. Now we're done with that pair. Now let's look at the next pair. Are those in the right order, smallest to largest? They are, so we don't do anything. The next pair, these are in the wrong order. Flip them. The next pair, these are in the wrong order also. Flip those. And so if we repeat this process a whole bunch of times, we're eventually going to end up with everything in the correct order. One thing you might have noticed from our quick demonstration here is once we get the largest item, it's just going to move all the way over to the right. So now we've got the second largest item. We're going to keep swapping it until it moves all the way next to the largest item. So after the first run, we had gotten the largest item all the way on the right side. After the second run, we got the second largest all the way over to the right side. After the third run, you can figure we're going to get the third largest item over there. So I'm going to just let this go, and it'll swap. We've got the third largest there. Now we need to do it again to get the fourth largest item. It turns out we didn't need to move anything there. And if we've got 4 of the 5 items in the right spots, then we must have all 5. So we repeat this process. If we've got 5 items, then we just have to repeat it 4 times. You can picture if we have 10 items, we'll have to repeat it 9 times. But we repeat this process where we just go left to right in our array, and we swap things that are in the wrong order. Just to show this quickly with a larger array, this is size 10, we're going to have the exact same process. We look at 2 items, we swap them. We look at the next 2 items and swap them because they're on the wrong side. We're going to do actually the same thing through here. You can see again, the largest item is just moving its way across the array because it swaps into the next spot, but then we use that spot and consider swapping it. So the largest item moves all the way left to right in one run through of our algorithm. The smallest item, however, it was all the way on the right side, it moved only one spot over, and that's one of the reasons we have to keep repeating this, is even though the large things might move quickly, the small things take a long time to move around. So after 2 run-throughs of our array, the 2 largest items are on the right side. So let's again just let this run, and we'll see how the third largest item now should end up, since we're doing the third run, should end up all the way over next to the others. And sure enough, there it goes. The third largest item is now in the third largest spot. What's happening though is the smallest item is only moving one spot to the left each time. So that's what takes the bubble sort a long time. We're getting the big items quickly to the right, but the small items are going pretty slowly to the left. As you're watching this, you may be thinking that there are some improvements we could make. We might be able to spot if our array is sorted even before we've done all the runs that we need to do. Or you might notice that when we get to the right side, maybe we don't need to do all these comparisons. We know these are already in the correct order. But for now, we'll start with the most basic type of bubble sort, where we'll just go through all the spots, even though some of them we know are in the right order. And we'll repeat this as many times as we need to guarantee that everything will end up in the right order. Let's look at how to do this sort in code. So I've loaded in the students from the file. I've put that in our students array, and I'm keeping track of how many students we loaded in from the file. Then I'm going to display the students, print a bunch of equal signs to just draw a line here, and sort the students, and then display them again. So let's run this. Right now our sort method doesn't do anything. So we're just displaying the students in the order they are in the file, and then not changing anything, displaying them in that same order again. But what we'll do is we'll write a sort method that'll sort them from highest to lowest. So after the line here, we should have students listed sorted if we do this all correctly. Let's start our sort method just by looking at the first two students. So we'll say if student at spot 0, if they're in the wrong order with the student at spot 1. So if their GPA, and if we want the highest first, they'll be in the wrong order if they have a lower GPA than the student at spot 1. So if this is true, then our first two students are in the wrong order. We need to swap them. So let's create a temp variable here. And swap our students. So this is only looking at the very first two students in our array, but let's see if it works. So we started with Charles Carson first, but we want the highest first. We swapped him with Thomas Barrow. So now when we're printing out our sorted array, we've only looked at the first two things, but they are actually in the correct order. We want to be able to do this repeatedly, so we're going to put it in a for loop. So we're going to say for int I equals 0, I is less than the number of students, I plus plus. And now instead of looking at spot 0, that'll be I. That'll be the current student we're looking at. So I'm going to replace 0 with I. And instead of comparing them always to the student at spot 1, the next student would be at spot I plus 1. So I'm going to replace it everywhere it says 1. I'm going to have I plus 1. So now we're going through our array once, looking at our current student, the person at spot I, and saying are they in the wrong order with the person after them. Now we're going to have one small error here. If I run this, we're going to have an exception. And that's in this line. That's because if we are looking at the last student is spot I, let's say there are 10 students, we're looking at I equals 9, and we're comparing them to the next student. Well, this is the last student. There is no student at spot 10. So we actually don't want to look at the last student. We want to look at everyone before the last student. So I'm going to say I is less than number of students minus 1. And here, if we run this, now we've gone once through our array. We should have the lowest student at the bottom. So remember, the way bubble sort works is we always kind of carry with us one person all the way to the end. In this case, we're going highest to lowest, so it's the lowest student will get carried all the way to the end. Now, it turns out Robert Crawley only moved one spot, but we still have guaranteed now the lowest student, the lowest GPA, is in the correct location. So now let's just repeat that a bunch of times. For int j equals 0, j is less than the number of students, and I can actually do that exact same comparison, minus 1. If there are 10 students, we need to repeat this process 9 times. So that'll do exactly that. And I'll scooch this all over. So I'm not actually using j inside of my loop. I'm just using j as a counter. If there are 10 students, I want to do this 9 times. If there are 100 students, I want to do this 99 times. So this for loop is just repeating something 99 times or 9 times or whatever the appropriate number is. And we're just doing whatever was in the for loop that many times. Let's run it, and we should hopefully have sorted students. Sure enough, Sarah O'Brien, the highest GPA is first, and it goes down from there.